Hello viewers, welcome to today's lesson. This is the solution space, the platform where mathematics is made easy and simple for everyone to understand and to enjoy. In this video, I want to treat a new topic with you, and that is algebraic expression. As you can see from the board, I've written algebraic expression on the board, and that's what I want to teach you in this video. Algebraic expression is one of the fundamental topics in mathematics which you cannot ignore. If you are going to excel in mathematics or enjoy mathematics, then you cannot be ignorant of the topic algebraic expression, because it's one of the bedrocks in mathematics, and we are going to apply its knowledge to almost all the other aspects of mathematics as well. So I'm not going to rush it. I'm going to take my time and lay a very good foundation to the topic algebraic expression, so that you can get a perfect understanding of it. So we are going to start from the basis, and we are going to start with addition and subtraction of algebraic expression. As you can see from the board, I've written addition and subtraction. Okay, so in this video, I'm going to teach you how to add and subtract algebraic expression. And you can also see that I have some examples on the board that I want to solve with you. But before we proceed and handle the examples that I have on the board, I'm going to do a brief explanation on the topic algebraic expression, so that when you gain the understanding, we can proceed and solve the examples that I have on the board together. Okay, so now when we speak of algebraic expression, it simply refers to the act of we conducting the four basic operations in mathematics on variables. Okay, and that is what is termed algebraic expression. Again, when we speak of algebraic expression, it simply refers to the act of we conducting the four basic operations in mathematics on variables, and that is what is referred to as algebraic expression. And I hope you all know the four basic operations in mathematics. They are addition, subtraction, multiplication, and division. So the act of we conducting these four basic operations on variables is what is termed as algebraic expression. I hope the explanation is clear enough up to this point. I'm going to explain it to the simplest form so that everyone can understand. Okay, so now you can all agree with me that we can add numbers, we can subtract numbers, we can multiply numbers, and we can also divide numbers. Again, you all know that we can add numbers, we can subtract numbers, we can multiply numbers, and we can also divide numbers. So in the same way we can add variables, we can subtract variables, we can multiply variables, and we can also divide variables. Okay, so the act of we adding, subtracting, multiplying, and dividing variables is what is termed as algebraic expression. I hope the explanation is clear enough up to this point. Okay, but there are rules that governs it. There are rules that governs the addition and subtraction of variables, and there are rules also that governs the multiplication of variables, and also there are rules that governs the division of variables. So we are going to take our time and look at all of them one by one. Okay, so in this video, we are going to start with how to add and subtract variables, which is the addition and subtraction of algebraic expression. Okay, so that in subsequent videos we will also look at the multiplication and division. Okay, now before we proceed, there is something very important that you need to know, because the knowledge of that is going to aid our understanding on how to add and subtract variables, which is the addition and subtraction of algebraic expression. Okay, so I'm going to do a further explanation, okay, on the board, then we'll go further. Okay, so now assuming I have, let's say I have 2a to the power 3. Okay, now if you've not seen anything like this before, you don't have to worry. I'm going to explain it to you, so just follow the explanation and you will definitely understand. Okay, so now this is pronounced 2a to the power 3 or 2a raised to the power 3. Okay, now this is the variable a, and you can see that I have a number in front of the variable, and also I have a number on top of the variable. Now there's a name that is given to them, so I'm going to identify it. Okay, then we can proceed. So now anytime you have a number in front of a variable, there's a name that is given to that number. And also anytime you have a number on top of a variable, there's a name that is given to it. Okay, so let's start with the number which is in front of the variable a. So we have 2, which is in front of the variable a. So that number is called the coefficient. Okay, again, anytime you have any given number in front of a variable, that number is called the coefficient of that variable. So in this case, we can see that we have 2, which is in front of the variable a. So the 2 is called the coefficient of the variable a. Okay, so let me write it on the board. So this 2 is the coefficient. The coefficient of the variable a. I hope you understand and you agree with me up to this point. Now, this a is the variable that I've been mentioning all along. Okay, so the a is our variable. Okay, so I'm going to label it as the variable. Okay, I hope you understand up to this point. And you can see that we have a number on top of the variable a. There's a name that is given to that number, and it is called the power or the exponent. Okay, so anytime you have a number on top of a variable, that number is called the power or the exponent of the variable. So the 3 here is called the power or the exponent. So power or the exponent. Good. I hope you understand up to this point. Now, I'm going to do a quick recap on whatever I've said up to now before we proceed. Okay, so now I wrote 2a to the power 3 on the board, and I'm saying that anytime you have any given number in front of a variable, that number is called the coefficient of the variable. Okay, and anytime you have a number on top of a variable, that number is called the power or the exponent of that variable. Okay, so now having 2a to the power 3 on the board, it means that the 2 which is in front of the variable a is called the coefficient, okay, and the 3 which is on top of the variable a is called the power or the exponent, okay. I hope the explanation is clear enough up to this point. Now, let's say I have this on the board. Let's say I have 5s to the power 7 on the board. And when I ask you of the coefficient and also the power, I hope you can tell me. Now, don't forget we've established that the number in front of the variable is called the coefficient and the number on top of the variable is called the power. So now we have 5 in front of the variable s, so the 5 is the coefficient and the 7 which is on top of the variable s is called the power or the exponent. Okay, I hope you understand up to this point. So this is our coefficient and this is our power. Okay, assuming I have, let's say I have 3c to the power minus 3. Okay, I have 3c to the power minus 3. If I ask for the coefficient, I hope you can be able to tell me the coefficient. The coefficient is 3 and the power is negative 3. The coefficient is the number in front of the variable. The power or the exponent is the number on top of the variable. So in this case, the coefficient is 3 and the power is minus 3. Take note of the sign. It is minus 3 and not 3. Okay, so the power here is minus 3. I hope the explanation is clear enough up to this point. Okay, now let me clean this and let's look at other examples. Okay, assuming I have minus 8y to the power 5, minus 8y to the power 5. If I ask for the coefficient is the number in front of the variable, so which is going to be the minus 8. Take note of the sign. It is minus 8 and not 8. So the coefficient here is minus 8. And if I ask for the power or the exponent, you know that the power or the exponent is the number on top of the variable. So the power is 5. Okay, again, the coefficient is minus 8. The power or the exponent is 5. I hope the explanation is clear enough up to this point. Now, what if I have something like this? Let's say I have only s on the board. I have only s on the board. So, what is the power? What is the coefficient? Now, you can see that I have only s on the board. There's no specified number in front of it, and also there's no specified number on top of it. So I'm saying that in that case, it means that the coefficient is 1 and the power is also 1. Okay, so unlike this one that I have 2a to the power 3, that you can see that I have 2 in front of the variable a and I have 3 on top of the variable a, which means that the coefficient is 2 and the power is 3. This one, we don't have any specified number in front of the variable and also on top of the variable. So in that case, I'm saying that it means the coefficient is 1 and also the power is 1. Okay. When the coefficient is 1, we don't write it, and when the power is also 1, we don't write it. Okay, so when you see a variable standing alone like this, it always means that the coefficient is 1 and the power is also 1. So you have to keep that in mind. Okay, so this is the same as s, because when we have 1s to the power 1, in mathematics is the same as S, because again, I've said that when the coefficient is 1, we don't write it, and when the power is also 1, we don't write it. But you have to keep in mind that when the variable is standing alone with no specified number in front of it, it means the coefficient is 1. And when there is no specified number on top of it too, it means the power or the exponent is also 1. I hope the explanation is clear enough up to this point. Now let me clean this one and write another one on the board. Let's say I have only B on the board. And when I ask you of the coefficient, I hope you should be able to know the coefficient. The coefficient is 1. And when I ask you of the power also, the power is 1. Because I just explained that if there is no specified number in front of the variable, it means the coefficient is 1. And if there is no specified number on top of the variable, it means the power or the exponent is also 1. Okay, I hope you understand. Now, what if I have something like this? Let's say I have b to the power 3. I have b to the power 3. If I ask for the coefficient, I hope you'll be able to know what the coefficient is. The coefficient is 1. The number in front of the variable. In this case, we don't have any specified number in front of the variable b, so it means the coefficient is 1, as I've already explained. Now, when I ask for the power is 3, okay, the number on top of the variable. So in this case, you can see that there's a specified number there, which is 3, so it means the power or the exponent is 3. Okay, now what if I have something like this? Let's say I have a 10b to the power 3. 10b to the power 3. If I ask for the coefficient, I hope you'll be able to know what the coefficient is. The coefficient here is 10 because now we have a specified number in front of the variable b, so the coefficient is 10. And if I ask for the power is 3. Okay, I hope the explanation is clear enough up to this point. Good. So now keep this in mind because it's going to aid our understanding on how to add and subtract algebraic expression. Okay, so please keep this in mind whilst I do a further explanation on how to add and subtract algebraic expression. Okay, so I'm going to clean this from the board so that I can do a further explanation before we start handling some examples. Okay, so let me clean this from here. Okay, so now when it comes to the addition and subtraction of algebraic expression, there are rules that governs it. Okay, again, when it comes to we adding or subtracting algebraic expression, there are rules that governs that operation. Okay, and one of those rules is that we can only add or subtract like terms. Again, one of the rules that governs the addition or subtraction of algebraic expression is that we can only add or subtract like terms. Okay, now when I say like terms, it means that of the same kind and of the same nature. Again, like terms means of the same kind and of the same nature. Okay, now I'm going to do some illustration on the board so that you can understand it. Okay, so assuming I have A on the board here and I have another A here. Okay, so now this A and this A are like terms. Why are they like terms? They are like terms because they are of the same kind and of the same nature. When I say of the same kind, it means that the variables needs to be the same. So you can say that I have A here, I have the same A here. The same variable is here, the same variable is here. So the A here and the A here are of the same kind. Okay, and also when I say that the variable needs to be of the same nature, it means they need to have the same power. Okay, again, when I say if the variables needs to be of the same nature, it means the variable needs to have the same power. So you can see that this variable here, it has power 1. Okay, I've explained this already, and I hope you understand that the power to this variable A is 1. And also the power to this variable A also is 1. So you can see they have the same power and they are of the same variables. Okay, so that is the meaning of the variables being of the same kind and of the same nature. Of the same kind means that the variable needs to be the same. So here I have A here, I have A here. Of the same nature means the variable needs to have the same power. So this A has power 1, this A also has power 1. Okay, so that is the meaning of like terms. Okay, I hope the explanation is clear enough up to this point. So anytime you want to add or subtract algebraic expressions, the variables needs to be of the same kind and of the same nature, and that is like terms. Okay, we can only add and subtract like terms. What it means is that if the variables are not like terms, you cannot add or subtract them. Okay, now let's say I have A to the power 3 and I have A to the power 2 on the board. Now this is A to the power 3 and this is A to the power 2. Are they like terms? No, they are not like terms. Why? Because this A has power 3 and this A has power 2. Okay, the variables have to be the same, which is true. We have A here, the variables are the same, but the power, they are not the same, so it means they are not like terms. This A has power 3, this A has power 2, so it means they are not like terms. The variables have to be the same, and also the variables needs to have the same power. So it means that this A to the power 3 and this A to the power 2, we cannot add or subtract them because they are not like terms. I hope the explanation is clear enough up to this point. Okay, let's say I have this on the board. Assuming I have 3s and also 5s to the power 4. I have 3s and 5s to the power 4. Are these like terms? No, they are not like terms. Why? Though this is variable s and this is also variable s, you can see that they have different powers. This variable s has power 1, this variable s has power 4, so they are not like terms. So it means that we cannot add or subtract this. I hope you understand up to this point. Okay, now, assuming I put power 4 here, are these like terms now? Yes, they are like terms. Why? Because this s has power 4, this s also has power 4, so it makes them like terms. So it means we can add them or subtract them. Okay, so we have 3s to the power 4, we have 5s to the power 4. the variables are the same, s here, s here, the powers are also the same, power 4 here, power 4 here, so it makes them like terms, meaning we can add or subtract them. I hope the explanation is clear enough up to this point. Let me take one more example before we proceed further. Okay, so I'm going to play this from here. Let's say I have y and s on the board. This is y and s. Are they like terms? Of course no, they are not like terms. Why? The variables are not the same in the first place for us to even now consider the power. Okay, so the y and the s are not like them, so we cannot add them or subtract them. Okay, now what if I put power 3 here and here's also I put power 3 here? Are they like terms? Again, no, they are not like terms. Why? The same explanation, the variables are not the same. This is why this is s, they are not like terms, the variables are not the same. Though the powers are the same, it doesn't mean they are like terms. For us to consider any variable being like terms, it means that the variables have to be the same, and also the variables needs to have the same power before we can consider it as like terms. Okay, so this is not like terms. Okay, unless I change this y to s, then now we can say that they are like terms because they have the same variables and they have the same power. Okay, then this is like terms. It means we can add or subtract them. I hope the explanation is clear enough up to this point. Now, I'm going to do the last one before we proceed. Okay, don't get bored. I said from the beginning that algebraic expression is one of the fundamental topics in mathematics. Okay, so I have to lay a very good foundation. Okay, that's why I'm taking my time to explain it a lot. So just follow all the explanation so that you can get a perfect understanding of it. Okay, so now let's say I have something like this. 6a squared and 3a to the power 3. I have 6a squared and 3a to the power 3. Are they like terms? No, they are not like terms. Why? This is a to the power 2, this is a to the power 3. So they are not like terms. Though the variables are the same, the powers are not the same, so they are not like terms. Okay, unless maybe I change this one also to power 3, then now we can say they are like terms. Okay, so for this now, we can say that they are like terms because this a has power 3, this a has power 3 also. They are like terms, the same variables, the same power. Okay, so then it makes them like terms. Okay, for the coefficients, we don't deal with the coefficients whilst we are considering whether it's like terms or not. We only consider the variables and the power it has to determine whether they are like terms or not. So don't let the coefficients confuse you. Okay, I hope you understand up to this point. Okay, good. So I'm going to clean this for us to go a step further on the explanation. Okay, now we've established that when it comes to the addition or subtraction of algebraic expression, we can only add or subtract like terms. Okay, and I've explained that a lot to you, that like terms simply means that the variables have to be of the same kind and of the same nature. And of the same kind means that if the variable is a, the next variable also have to be a. Okay, Now, of the same nature means that they need to have the same power. The variables have to have the same power, okay, before we can consider them to be like terms for we to add or subtract. Okay, I hope the explanation is clear enough up to this point. Okay, so now, when it comes to we adding or subtracting variables, which is the addition and subtraction of algebraic expression, we deal with the coefficient. Okay, after we've checked that they are like terms, for us to add them or subtract them, we deal with the coefficient. Okay, so example, if I have 5s minus 3s on the board, if I want to simplify this one, first of all, let's check if they are like terms. This is s, it has power 1. This is also s, it has power 1. So of course, they are like terms. So it means we can subtract. Okay, so I have 5s minus 3s. And I'm saying that for us to conduct the subtraction or addition, we deal with the coefficients after we've confirmed that the variables are like terms. If you want to conduct the addition or subtraction, it's the coefficient of the variables that we deal with. Then we just pick one of the variables and attach to it. So let's do it for you to see. Okay, so now the coefficient of this s is 5. The coefficient of this s is the minus 3. So we have 5 minus 3. So we are going to deal with the coefficient. 5 minus 3 gives 2. Then you just pick one of the variables and attach to it. So you will have 2s as your final answer. I hope the explanation is clear enough up to this point. Let me just go over one more time. We have 5s minus 3s, and I'm saying that for you to do the simplification, we deal with the coefficient. The coefficient of this s is 5. The coefficient of this s is minus 3. Okay. Now, for us to subtract them, we do the 5 minus 3. We deal with the coefficient. 5 minus 3 gives 2, and you just pick one of the variables and attach to it. That's why we are having 2s as our answer. I hope the explanation is clear enough up to this point. Now, let's say that I have 5s plus 3s. 5s plus 3s. We are adding now. It's the same principle that governs it. We are going to deal with the coefficient and just pick one of the variables and attach to it. So 5 plus 3 is going to give me 8. Then I'll just pick one of the variables and attach to it. So I'm going to have 8s as my final answer. I hope the explanation is clear enough up to this point. Let's take another example for us to see how it goes. Let's say I have 7a squared minus 3a squared. Okay, we have to simplify this one. 7a squared minus 3a squared. First of all, let's check if the variables are like terms. Now, this is a, this is a. This a has power 2, this a also has power 2. So they are like terms, so we can simplify this one. We can do the subtraction. How do we do the subtraction? I say that we deal with the coefficient and just pick one of the variable and attach to our answer. So it's going to be 7 minus 3. 7 minus 3 gives 4. Then you just pick one of the variables and attach to it. So I'm going to have 4a squared as my final answer. Okay, that is we subtracting or adding algebraic expression. That is the rules that governs it. I hope the explanation is clear enough up to this point. Let me clean this and let's take some few more examples before we proceed further. Let's say I have 3s plus s plus, let's say, 2s. To simplify this one, it's the same process. You don't have to get confused. We are going to deal with the coefficients. Since they are like terms, it means we can add them. Why are they like terms? This is s, it has power 1. This is s, it has power 1. This is s, it has power 1. So they are like terms. We can add them. How do we do the addition? We deal with the coefficient of the variables. So the coefficient of this s is 3. The coefficient of this s is 1. I hope you remember I explained this to you earlier. So the coefficient of this s is 1 and the coefficient of this s is 2. So it's going to be the 3 here plus the 1 here plus the 2 here, which is going to give 6. I hope you agree with me. Then we just pick one of the variables and attach to it. So we are going to have 6s as our final answer. I hope you understand and you agree with me. Let's take another example. Let's say I have 12a to the power 3 minus 7a to the power 3 minus a to the power 3. First of all, let's check if they are like terms. Okay, this is a to the power 3, this is also a to the power 3, this is also a to the power 3. So they are like terms. We can do the simplification. Okay, so you can choose to do the first two, then join it with the last one, then you get your answer, or you can choose to do them together. Now, how do we simplify? We deal with the coefficients. The coefficient of this a to the power 3 is 12. The coefficient of this a to the power 3 is minus 7. And the coefficient of this a to the power 3 is minus 1. I hope you agree with me, because there's one here that we don't write. I hope you understand. So now, we are going to do our 12 minus 7. 12 minus 7 gives 5. I hope you agree with me. 12 minus 7, it gives 5. And that 5 minus 1, because the coefficient here is minus 1. Again, 12 minus 7, it gives 5. And that 5 minus 1, it gives 4. So our answer is going to be 4a to the power 3. As I said, you just deal with the coefficients, then you just pick one of the variables and attach to it. Okay, so that's how you go about it. Let me clean it and let's take another example. Okay, let's say I have a minus 3s plus 5s plus 10s. I have minus 3s plus 5s plus 10s. We can simplify. Why? Because they are like terms. This s has power 1, this s has power 1, this s has power 1. The same variables with the same power, so they are like terms. How do we add them or subtract them? We have minus 3s plus 5s plus 10s. We deal with the coefficient. Then we just pick one of the variables and attach to it. Okay, so now the coefficient of this s is minus 3. The coefficient of this s is positive 5. And the coefficient of this s is positive 10. So it's going to be minus 3 plus 5 plus 10. So let's do it together. Minus 3 plus 5, it gives positive 2. I hope you agree with me. Minus 3 plus 5, it gives positive 2. And that positive 2 plus the 10, it gives positive 12. Okay, so simplifying this one, we are going to have 12x as our final answer. I hope you understand up to this point. Okay, so again, minus 3x plus 5x plus 10x, we deal with the coefficients. Minus 3 plus 5, it gives positive 2. And that positive 2 plus 10, it gives positive 12. So we are having 12x. So this is our final answer. Okay, now, if you are wondering how come we are getting positive 2 for adding this and this, there's a simple way to understand it. Okay, now your knowledge on addition and subtraction of integers have to be very strong. Okay, now this is minus 3, this is positive 5, we are adding them. Consider the negative number as the money you are owing and consider the positive number as the money you are having. Again, always consider the negative number as the money you are owing and consider the positive number as the money you are having. And anytime you are owing, when it comes to mathematics, you have to pay back. Anytime you are owing, you need to pay back. Don't forget, consider the negative value as the money you are owing and the positive value as the money you are having. So in this case, minus 3 plus 5, the negative 3 is the money I'm owing, so I'm owing 3. The positive 5 is the money I'm having. And I've said that anytime you are owing, you have to pay back. So if I'm owing someone 3 cedis, okay, and I'm having money of mine, which is 5 cedis, when I pay back, I will have 2 cedis left, which is mine. I will not be owing. Minus 3 plus 5, it gives positive 2. So that's the meaning. So I'm owing someone 3, I have money of 5, I pay back, and I'll not be owing the person. I'll have 2 left, which is mine. So minus 3 plus the 5, it gives positive 2. And that positive 2 plus the 10 here, it gives positive 12. That's why we are having 12s. I hope the explanation is clear enough up to this point. Okay, good. Let me clean it and take some other examples. Let's say I have 6y minus 9y plus y. I have 6y minus 9y plus y. We have to simplify this one. First of all, they are like terms, so we can simplify them. Okay, how do we simplify them? We deal with the coefficients. So it's going to be 6 minus 9. 6 minus 9 gives negative 3. And the negative 3 plus the coefficient here, which is 1, it gives negative 2. I hope you agree with me. Let's do it one more time. It's very simple. Follow the explanation. 6 minus 9, it gives negative 3. And that negative 3 plus the 1 here, there's a coefficient of 1 here, it gives negative 2. I've already explained that. Consider the positive number as the money you are having and the negative number as the money you are owing. So if I have money of 6 and I'm owing someone 9, I pay back and I'll still be owing the person 3. So this 6 minus 3 gives negative 3, then plus the coefficient here, which is the 1. And minus 3 plus 1 results in minus 2. Okay, I hope the explanation is clear up to this point. So 6y minus 9y plus y, our final answer is going to be minus 2y. Okay, I hope you understand and you agree with me up to this point. So this is how to handle addition and subtraction of algebraic expression. Okay, now what if we have the case where you have different variables in the question? What do we do? Then it means we need to group like terms. In the case where you have different variables in the question, what you have to do is that you group like terms. So I'm going to take two examples to explain it to you before we proceed and handle the examples that I have on the board. Okay, so let me claim this from here and let's proceed. Okay, so assuming I have, let's say, s plus s plus y plus s plus another y. Okay, let's say I have this example on the board and we are being asked to simplify. Now you can see that we have different variables mixed together in the question. We have s in it and we have y in it. So in this case, what we do is that we group like terms before we can go ahead and simplify. Grouping like terms simply means that we are going to group all the s at one side and we are going to group all the y at another side. Then we'll proceed and simplify. Okay, so I'm going to look through it and I'm going to group all the s together, then also group all the y together. Then I'll proceed and simplify further. That is we grouping like terms. Okay, so now I'll start with the s. I'll pick this s, then I'll join it with the s which is here. And when you are picking the variable, you pick it with the sign in front of it, which is very important. Again, when you are picking the variable, you pick it with the sign in front of it. So starting with this s, I'm joining it with the s here. The sign in front of the s which is here is addition, so I'll pick it with the sign. So plus the s. Then you can see there's another s also here, so I'll pick it and join it to it. So the sign in front of it is plus, so you pick it with it, so plus the s. So I'm done grouping all the s, so then I'll proceed and group all the y also. So starting with the y here, you pick it with a sign in front of it, so plus y, then I'll join it with this one, plus y. So that is me grouping like terms. Okay, so anytime you have the variables mixed together, different variables mixed together, you group like terms before you simplify. So now let's go ahead and simplify. S plus s plus s is going to give 3s, and I hope you understand and you agree with me because I've explained this a lot. Okay, we deal with the coefficients. The coefficient of this s is 1, the coefficient of this s is 1, the coefficient of this s is 1. So 1 plus 1 plus 1, it gives 3. And you just pick one of the variables and attach to it as you have been doing. Okay, then plus the y here is going to give me 2y. Then this becomes my final answer. Okay, this we cannot simplify further because the variables are not like terms. Okay, this is s, this is y. We cannot add them again. So we leave our final answer to be like this, which is the 3s plus 2y. I hope the explanation is clear enough up to this point. Let me take another example and use it to explain it to you. Okay, so I'm going to clean this from here. Assuming I have, let's say I have 3a minus 10b plus 5a minus 2b. Okay, 3a minus 10b plus 5a minus 2b. To simplify this, you can see that we have different variables mixed together. So what do we have to do? we group like terms. That's the first thing to do. Okay, so I'm going to group all the A at one side and I'm going to group all the B at another side before I can simplify further. So when I pick this 3A, I'll look for the one which also contains A to join with it, and which is this positive 5A. Don't forget you pick it with a sign in front of it. So plus the 5A, so I'm done grouping the A. Then let's go to the B. I have minus 10B here. Okay, you pick it with a sign in front of it, minus, so minus 10B. Then I'll join it with the minus 2B, which is here. Okay, that is the grouping of like terms. Okay, then now we can go ahead and simplify further. 3A plus 5A, it gives 8A. I hope you agree with me. Now, minus 10B minus 2B, it gives minus 12B. And I hope you understand. This becomes my final answer, which we cannot simplify further because this is A, this is B. They are not like terms. So this becomes my final answer, A minus 12B. I hope the explanation is clear enough up to this point. Now, in case you are wondering how I got the minus 12B, this is minus 10B minus 2B. How did we end up getting minus 12B? I've explained to you that consider the negative as the money you are owing. Okay, now I have minus 10B, so I'm owing 10. Again, I have minus 2B, so I'm owing another 2. So if you are owing someone 10 and at the same time you are owing another 2 again, the person another 2, in all you will be owing the person 12. Okay, that's why we have minus 12B, because there isn't any positive number there to pay back. Okay, so the minus 10B minus 2B, it gives minus 12B. Okay, so in case you don't understand how come we got the minus 12B, that's the explanation. Okay, and this we are applying the knowledge on addition and subtraction of integers. Okay, that's what we are applying here. I hope the explanation is clear enough up to this point. Let me clean it and pick the last one before we proceed and handle the ones that I have on the board. Okay, so I'm going to clean it so that we can try another example. Okay, let's say I have a minus sy plus 3ab minus sy minus 4ab. Okay, let me clean it and write it all so that everything will go there. So minus 4ab. Good. Now we have to simplify this. You can agree with me that we have different variables mixed together. So what do we have to do? We group like terms. We have sy in it and we have ab in it. So we are going to group all the sy at one side and all the ab also at another side. Okay, that's we grouping like terms. So when I pick this minus sy, I will join it with the one which also contains sy, and that is this minus sy. So I'll join with it. Okay, we are grouping like terms. Don't forget, I say you pick it with a sign in front of it. So minus this sy. Then I'll now come to the ab as well. So starting with this one plus 3ab, then I'll join it with the minus 4ab. I hope the explanation is clear enough and you understand also. Now let's go ahead and simplify further. Minus sy minus sy is going to give minus 2sy. And I hope you know why we are getting the minus 2sy. Now, consider the negative as the money you are owing. So I'm owing someone 1. At the same time, I'm owing the person 1 again. So in all, I'll be owing the person 2. That's why we have minus 2 sy. Okay, so minus 1 minus the 1 here gives minus 2. So minus 2 sy. I hope you understand. Let's come to this one. I have positive 3ab minus 4ab. Again, we deal with the coefficients. Don't forget, that's what we have been doing all along. So 3 minus 4, it gives negative 1. Again, 3 minus 4, it gives negative 1. I've explained that consider the positive number as the money you are having and the negative number as the money you are owing. So if I'm having 3, okay, that is the money I'm having, positive 3, the money I'm having, and I have negative 4 here, that is the money I'm owing. Okay, so 3 minus 4, I have money of 3, I'm owing 4. So if I have 3 cedis and I'm owing someone 4 cedis, I pay back and I'll still be owing the person 1 cedi. Is that not it? So it's going to be minus AB. I hope you understand. Maybe someone is wondering, why didn't I bring the 1? Okay, if you write minus 1AB, it's the same thing. You are not wrong. But earlier in this video, I explained to you that when the coefficient is 1, there's no need writing it. Okay, so minus 1AB is the same as minus AB. So you write it like this. If you write the minus 1AB, there's nothing wrong with it. You'll be marked correct. Okay, just that we know that when the coefficient is 1, there's no need to write it. I hope you understand. So this becomes our final answer that we cannot simplify further because they are not like terms. This is sy, this is ab. They are not like terms. So this is our final answer. Minus 2sy minus ab. I hope the explanation is clear enough up to this point. Okay, now with this understanding, we can now proceed and handle the examples that I have on the board. So let's do the examples that I have on the board together. Okay, so I'm going to clean this so that we can have enough space to tackle the examples. Okay, so now let me write down my solution and let's start with the A. So the A, I have 5s plus 4 minus 9y plus 3s plus 2y minus 7. Okay, so we are to simplify this one. So what we need to do, we first have to group like terms as I've explained to you. Okay, so let's start with the s. So when I pick my 5s, I'm going to look for the one which also has s in it to join with it. Okay, and which is the 3s, which is here, but you pick it with a sign, very important. So plus the 3s. Then I move on to the numbers also. I have 4 here, so I'll look for the number in it and join it with it as well. So plus the 4, then the minus 7 will come. I hope you understand up to this point. This is positive 4, so its like term is the negative 7. You join with it. Okay, then I move on to the y. So starting with this minus 9y, so I'll write my minus 9y. Then I'll look for the one which also has y in it and join to it, which is the positive 2y. So plus 2y. I hope you understand and you agree with me up to this point. From here, we just need to simplify further. Okay, 5s plus 3s, it gives 8s. Okay, now positive 4 minus 7, it gives minus 3, and I hope you understand why it's minus 3 because I've explained this a lot. Okay, now minus 9y plus 2y, it gives minus 7y. This now becomes my final answer, which I cannot simplify further again because we don't have any like terms in it. So this is my final answer. I hope the explanation is clear enough up to this point. Okay, now the 4 minus 7, it gives minus 3. Let me explain. I've already said that consider the positive number as the money you are having, consider the negative number as the money you are owing. So positive 4 here is the money I'm having, negative 7 here is the money I'm owing, and anytime you are owing, you have to pay back. So if I'm having a money of 7, money of 4, okay, because it's positive 4. If I'm having money of 4 cedis and I'm owing someone 7 cedis, I pay back and I'll still be owing the person 3 cedis. Okay, so 4 minus 7, it gives minus 3. What shows that you are owing is that you bring the negative sign. Okay, so minus 3. Okay, so the 4 minus 7, that's why we have minus 3 here. And this one, minus 9y plus 2y. Again, consider the negative as the money you are owing, the positive as the money you are having. So minus 9y, the minus 9 is the money I'm owing, and the 2y, the 2 is the money I'm having. So when I pay back, I'll still be owing the person 7. That's why we have minus 7y here. I hope you understand now. So this becomes our final answer that we cannot simplify further again. I hope the explanation is clear enough up to this point. Now let's go ahead and handle the B also, okay, the example B. So I'm going to clean this from here so that we can have enough space to do the example B. I hope you understand. So let me clean this and let's tackle the B as well. Okay, so the example B, I have 4s plus 2y plus 3s plus 5y. Okay, so we have to simplify this one, okay, because the question says simplify the following. So we are simplifying. Now, we have to first group like terms because we have different variables mixed together in it. We have s in it, we have y in it, so we are going to group all the s at one side and all the y at another side. Okay, so now, starting with this 4s, so when I take my 4s, I'll look for the one which also have s in it and attached to it, which is the positive 3s, which is here. So plus 3s. Then we group the y also. So starting with this plus 2y, then I'll join it with the plus 5y. I hope you understand up to this point. Let's go ahead and simplify. 4s plus 3s, it gives 7s. Okay, I hope it's very simple enough for you to understand. 4s plus 3s, it gives 7s. Then 2y plus 5y, it gives 7y. Okay, now this becomes our final answer, which we cannot simplify further again because the variables, they are not like terms. This is s, this is y. They are not like terms. We cannot simplify further. So this becomes our final answer. We leave it like this. Okay, good. Now let's go ahead and do the example C as well. So I'm going to clean it so that we can have enough space to do the example C. So let me clean this from here and let's do the example C. Okay, so the C, I have 2p minus 3q plus 3p plus 5q. So what do we do? The same process, we have to group like terms. Very important. So we group like terms. So when I take this 2p, I'll look for the one which also has 2p in it and join with it. Okay, which is the positive 3p. So plus 3p. Then I'll group all the q as well. So my minus 3q will come, then plus the 5q. Okay, let's go ahead and simplify. 2p plus 3p, it gives 5p. Okay, so 5p. Then minus 3q plus 5q, it gives positive 2q. I hope you understand. I've explained this a lot, so I hope you understand now. Good. So this is our final answer, which we cannot simplify further because the variables are not like terms. This is p, this is q. We cannot simplify further. Okay, so this is our final answer. Now let's go ahead and tackle the d. Okay, so I'm going to clean this one so that we can have enough space to tackle the d. Okay, so the d, I have 4s squared y plus 5sy squared plus 3s squared y minus 2sy squared. Okay, so we have to simplify this. Again, we have to group like terms. Please take note that s squared y is not the same as y squared, sy squared. Again, please take note that the s squared y is not the same as sy squared. They are different. They are not like terms. For the last time, this is s squared y. It is not the same as sy squared. No, they are different. They are not like terms. Okay, so we are going to check very well to group the like terms. Okay, now, so when I take this 4s squared y, I will look for the one which also have the s squared y and join with it. Okay, now which one have the s squared y is going to be the plus 3s squared y. I hope you agree with me. You need to take your time and check very well. So I'll join it with the plus 3s squared y. Very good. Then followed by my plus 5sy squared. Then you look for the one which also have the sy squared in it and join with it, which is the minus 2sy squared. So that's it like that. So minus 2sy squared. I hope you understand up to this point. Very good. Then we can go ahead and simplify further. So now this 4s squared y plus the 3s squared y is going to give me 7s squared y. Okay, then now 5sy squared minus 2sy squared is going to give me plus 3sy squared. Okay, now this becomes our final answer, which we cannot simplify further. Why? Because they are not like terms. The variables are not like terms. The s squared y is not the same as the sy squared. They are different. So this is my final answer. I leave it like this. I hope the explanation is clear enough up to this point. Okay, now let's handle the last one, which is the e. Okay, so I'm going to clean this from here so that we can do the last one, which is the e. Example e. Example e. I have s squared plus s plus 2s squared. Okay, please take note that we need to group like terms because this is s squared, this is s. They are not the same. They are not like terms. Okay, so we are going to group like terms. So when I pick the first one, which is the s squared, I'm going to look for the one which also have s squared in it and join to it, which is the 2s squared. so plus the 2s squared, then followed by my plus s. Okay, that's the only s there, so you just put it there. Now let's go ahead and simplify. This s squared plus 2s squared is going to give me 3s squared, and I hope you understand why. The coefficient of this s squared is 1, so 1 plus the 2 gives 3. You just pick one of the variable and attach to it, so 3s squared. Okay, then plus this s. That's it. We leave it like this. This becomes our final answer because this s and this s squared, they are not like terms for us to add them. We can't add them. I've explained this a lot earlier in this video. Okay, that like terms means that the variables have to be the same and they need to have the same powers as well. This s has power 2, this s has power 1, so they are not like terms that we can add. So you leave it like this. You just join the s like this and you are done. I hope the explanation was clear enough and you understood it as well. Okay, so thank you, and please don't forget to like the video and also share the video. And if you are watching for the first time, please do well to follow the page and also subscribe to my YouTube channel as well. I'll see you again in another video whilst we handle the multiplication and division of algebraic expression. Bye bye.